Let us find the limit of cos x divided by x as x tends to 0. We are going to use the L'Hopital's rule, but just before we do that, let's see if we can use another method. Let's use a number that is close to 0. Right? So here, suppose we get our calculator. We want to have our calculator and find the cos of a very small number divided by that same number. Alright? Alright. So here, cos x divided by x. So I have 0.1 cos of that divided by 0.1 equal 9.95. Suppose we try again. 0.01 now cos divided by 0.01 equal 99.995. It's about 100. Let's use a smaller number. 0.001 cos divided by 0.001 equal 999.999 and so on, nearly 1,000. So we're getting larger and larger. So let's consider a negative number now and see what happens. Say we have 0.01 negative cos of that divided by 0.01 negative number equal, you have negative 99.995. Alright, so we are seeing that when you put in small positive numbers, the answer shoots up to positive infinity, and when we put in negative numbers, the answer goes down to negative infinity. Is it positive or negative infinity? Interesting. Let us just make a note here. For values to the left, negative values and approaching 0, it is negative infinity. And for positive values, that means from the right going back down to 0, is positive infinity. What would happen if we use L'Hopital's rule? Let's see something. Remember what L'Hopital's rule says is that the limit of f of x divided by f prime x divided by f g of x, divided by g of x as x tends to 0. Well, it couldn't be any number, say a, as x tends to a, is equal to the limit as x also tends to a of, when you differentiate its function, f prime x divided by g prime x. So we're going to differentiate cos x and also x and substitute. So what we're trying to find is the limit as x tends to 0 of, when you differentiate cos x, you get sine x divided by x, which is, when you differentiate x, you get 1. So when you substitute directly, what you get is sine of 0 divided by 1, which is 0 over 1, which is 0. Interesting. What would be good is if we look at a graph of this function and see what it looks like, because it seems as if the limit doesn't exist. Now let us look at the graph finally and see what's going on. Let's use GeoGebra graph plotter. Alright, so let me just make an adjustment here. to our graph plotter. I want to move our graph plotter. Alright, let's move it here. I want to move it down a bit. Okay. Alright. Let's see what's going on. I need to collapse this some more. I need to fill out, well, at least make more use of the screen. Alright, so we have cos of x, and that is divided by x. Enter. Oh, that's the graph. Let me make the curve thicker so you can see exactly what's going on. Alright. So here we go. F of x is cos x divided by x. What we see is on the right, going down towards 0, it's shooting up towards positive infinity, and on the left, going to the right towards 0, it's shooting down towards negative infinity. So, just as we did when we were looking at numbers close to 0, but not touching it, we wouldn't be able to touch 0 because that will give us an undefined value. But when we use L'Hopital's rule, it gives us 0. So L'Hopital's rule is taking the mid value between the left and the right and giving us 0. But it's not 0. The limit is really not 0. The limit doesn't exist. Now, L'Hopital's rule doesn't work for all functions, and it didn't work for this one because it gave us 0. But obviously, the limit does not exist. Alright? So, that's what you can say about the limit as x tends to 0 of cos x divided by x. It doesn't exist.